My name is Alex Timofeyev, and I'm the product marketing lead for Equinix Colocation and xScale data center services. And that gives me the privileged position of working on our liquid cooling solution development. And right now, that means I'm experiencing liquid cooling myself. They say that water conducts heat about 25 times more efficiently than air does. But I had to find out for myself, because apparently some people only learn from their mistakes. Now, sadly, I couldn't record the entire webinar from this cold plunge, so this is a nice little pre-recorded session for you all before I join Lindsay Schulz live in a moment. And today, we're going to cover liquid cooling, and we'll be talking about, one, the pain points that enterprises are experiencing when trying to deploy liquid cooling, two, some of the key considerations when deploying liquid cooling, and three, the simplest path to deploy liquid cooling today. Without further ado, please enjoy your webinar. Wish I could say I was coming in hot, but I'm coming in a little cold here. Refreshing though, refreshing. You guys should try it. As I mentioned before, my name is Alex Timofeyev. I do product marketing here for data center and colocation, which gives me the privilege of working on our liquid cooling solution. I am joined by the awesome Lindsay Schulz. Lindsay is our global principal technologist. Yeah. There we go. I think I'm safe when I say that you were the first person to design a GB200 liquid cooled data center footprint inside a colocation data center.
Yes, along with our amazing team here at Equinix. But yes, I was one of the individuals that did work on that.
Okay. So when Lindsay's not busy designing GB200 footprints for us, she's helping us drive our strategy and solution for liquid cooling, primarily by being our boots on the ground. Lindsay, you work all the time with the leading enterprises in the world, helping them design and deploy their liquid cooled solutions at Equinix. And I feel very privileged to be able to tap into the knowledge that you have because of that. So I think this is a really, pivotal moment in liquid cooling, right? If you're familiar with the Gartner hype cycle, the way we sense it is that we've sort of passed the peak of the hype. Mm-hmm. We've come down through the trough of disillusionment, as Gartner calls it. And we're seeing a very sort of rational adoption curve of liquid cooling, where enterprises are sort of rationally considering liquid cooled deployments based on real workloads and real sort of use cases and ROI. And so we sort of anticipate that that liquid cooling is going to continue to grow, and that we're going to see more and more of our customers coming to us, asking us for help in the liquid cooling space. But before we get into the sort of liquid cooling of it all,
yes,
I wanted to start by talking about how we got here. When you're talking to the enterprises of the world on your day-to-day, what do you see as the primary push that drives them to adopt or consider liquid cooling in the data center?
Yeah, absolutely. So the major driver in the industry right now is actually the chipsets inside of the servers, primarily GPUs as of now as well. But when we take a look at the TDP or thermal design power, essentially the heat capacity or the amount of the density of these chips in the servers and how that has increased over time, it's just increasing exponentially. If you look back prior to the year 2020, even just a decade prior, really we saw that the TDP only increased minimally year over year. And now we're seeing it jump up on an exponential curve. And that's really what's driving liquid cooling, because when you get to certain densities, like the latest GB200 GPU, you just can't cool that with air cooling. It's 1.2 kilowatts. Yeah. So that's really why we're turning to liquid cooling.
So it sounds like it's primarily like a GPU thing, right, and AI driven. But are we seeing similar trends in densification or even liquid cooling adoption for CPUs or networking and storage, or is it really just a GPU thing?
Yeah, absolutely. The trend is definitely across the board with all chipsets. Yeah. GPUs are just sort of leading the pack right now in terms of liquid cooling, but we are seeing densification across the board. Right. Just higher density air-cooled racks, I'd say, on the CPU front right now, but likely CPUs will follow with liquid cooling in the next few years as well.
And am I correct? I think I heard Jensen mention that building some or designing some liquid cooled like switching infrastructure?
Yeah, well, they're definitely innovating the way their switches operate.
Yeah.
So as he mentioned, when you are interconnecting all these GPUs to one another, there's just a ton of transceivers that are needed. These are very high-powered transceivers. The bandwidth that's going across these fibers is very high.
Yeah.
So each of those individual transceivers, though minimal, adds up to your power budget.
Right.
And so by innovating the switch technology and then potentially in the future making switches liquid cooled as well, that's a way that you can kind of bring some of that power back to the GPU utilization.
Sure. It's a brave new world for networking.
Yeah, absolutely.
In the context of this being primarily driven by AI and GPUs, can you talk a little bit about why liquid cooling is so paramount for AI and kind of high performance compute in the sense of, how we used to accommodate densification in the data center versus what is required for high performance compute type deployment?
Yeah, so previously, if we had dense cabinets in the data center and we were limited on cooling, we could possibly space the servers out in more racks, or we could space out the racks. Yes, there would be some costs in terms of cabling increases, but in the past, we could do structured cabling to connect the servers to one another and to the switches. But when we look at GPU workloads and just the way that AI works, especially when we look at training models, the GPUs really work all together almost as one big supercomputer. And because of that, they're all cabled point to point. And that mesh of cables, there are so many fibers that connect these systems to one another, that you really want to, that distance matters. So we want to get the cabinets as close as possible together. We want to pack as many GPUs and as many servers into each rack as we can, so we can limit that cable cost and lower the attenuation as much as possible.
Yeah, I mean, I was fortunate enough to see one of these AI GPU deployments, and I mean, the amount of cabling in that cage is just mind-boggling.
It's
You
insane.
can think, if you have several hundred or even 1,000 strands of fiber running between racks, every foot counts in terms of cost and even in terms of latency between packets between GPUs. So I can see why that's it's paramount to move everything closer together. Pulling on that thread a little bit, can you talk a little bit about the limits of air cooling? Do we see a sort of power density limit to air cooling? Is there a way to accommodate denser deployments with air cooling still?
Yeah, absolutely. I'd say we absolutely can accommodate higher density with air cooling. There's other technologies we can use. So some of the densities we're seeing even in previous chipsets that aren't necessarily required for liquid cooling. The GB200 was actually the first one that actually 100% requires liquid cooling. Previous chipsets, you could go either way, liquid cooled or air. But even the air cooled servers with those chipsets are very high density. And so there are some ways that we can support that through augmented air technologies like in-row coolers or rear door heat exchangers. But those do leverage liquid in the data center as well. So in some ways, they're sort of lumped in with liquid cooling, even though they aren't true liquid cooling at the chip. So you're just extending that facility liquid infrastructure that backs our air cooling infrastructure today closer to the customer deployment.
How does liquid cooling affect data center efficiency and sustainability? Are there positive outcomes by implementing liquid cooling for denser deployments in those spaces?
Yeah, so liquid cooling is definitely more of an efficiency play than sustainability play, but focusing on efficiency for your organization can have long-term sustainability implications. Now, from an efficiency standpoint with liquid cooling, it's really more focused on the efficiency of the servers, I'd say right now. So especially when a customer has an option to either go a liquid-cooled server or an air-cooled server. You will see efficiency gains if you go the liquid-cooled server because you're putting less power towards the utilization of fans and whatnot. From a facility standpoint, we can see some efficiency gains as well, but really it's when you are purpose building a facility for liquid cooling. So I would say as we see the liquid cooling trend increase in the industry, we'll start to see data centers that have a higher and higher percentage of liquid cooling workloads in their data centers. And as that grows, you'll start to see some of those efficiency gains at the facility level as well.
So it sounds like, liquid cooling can drive server level efficiency for sure by, reducing the amount of, power sent to the fans. Is there a server performance aspect to that where more of the power is maybe diverted to the chipsets as opposed to the fans as well?
I think it's just your power budget, right?
Yeah.
So the amount of power that, especially if you're working with a data center provider, the amount of power that you might be contracting, more of that power can go towards your actual compute and workloads as opposed to, elements of the server just to help the server operate.
Sounds like, liquid provides these sort of benefits as opposed to air, especially in these dense systems. But I want to pivot a little bit away and talk about, some of the challenges you see enterprises face when considering liquid cooling. Mm-hmm. So I know you work with enterprises on the daily on liquid cooling. And so when they come to us, what are they typically considering or challenged with when they want to deploy liquid cooling?
Yeah, so I'd say the biggest challenge is, if a customer, for example, is trying to do this on-prem, there's so many components you have to think about now. Essentially liquid cooling is plumbing. So now you have to consider plumbing in your facility and the power as well. And we're talking cabinets that are over 100 kilowatts now for GPU workloads. So just the power distribution to that, handling the cooling. And we talk about liquid cooling, but these racks, only a portion of them are liquid cooled. We're cooling at the chips, and they still have a pretty high air cooling budget as well. So all of these things combine to make challenges for customers. So they're really starting to lean more on their OEM partners, liquid cooling vendors, and data center providers like Equinix to support them in that journey to help with the infrastructure that they need.
Sure. I want to pull a thread of a detail that you just sort of brought up, which is sort of, a lot of these, especially direct-to-chip, cooled systems, still require air cooling.
Yes.
Right.
Yeah.
And when we're talking about, a rack that requires over 100 kVA of power, mm-hmm. right? What is the typical split of cooling between liquid and air? And then maybe we can sort of reverse engineer the math of like, okay, this is how much is liquid cooled versus air cooled.
Yeah.
Yeah.
It does depend, but I would say for the most part, the trend we're seeing is around like an 80-20, 85-15 split in the industry right now. So yeah, so if you're looking at a 100 kilowatt rack, you still have 20-ish kilowatts that you have to air cool.
Right.
Yeah.
Which is still considered a dense, right, air cooled deployment.
Right, exactly.
Okay.
Yeah.
And so, I think that points to this sort of level of complexity, right, that mm-hmm. that exists when as you dense up within your infrastructure. Do you see that traditional data center infrastructure teams are well staffed to sort of tackle this challenge?
You mean like at the customer or the data center level?
Yeah, like customer,
mm-hmm.
customer, enterprise infrastructure teams. Are mm-hmm. they typically well, staffed and skilled to sort of overcome some of the new complexities and challenges of liquid cooling and densified data centers?
Yeah, I'd say maybe not necessarily innately. Can't speak for every customer, but as I mentioned, like essentially we have plumbing in the data center now. So unless you have mechanical engineers on your data center infrastructure staff, some of these are new challenges and new components that many customers are not familiar with, and they're hoping to lean on a data center provider in order to provide that guidance and support for them.
It sounds like, there's benefits to be gained by sort of leaning on the expertise that exists out in the market. Mm-hmm. Do you see, OEMs and liquid cooling vendors sort of stepping up to help simplify some of those challenges mm-hmm. and complexities? And do you see enterprises sort of working closely with different partners? And if so, what kinds of partners?
Yeah, absolutely. So in order to simplify, the OEMs are creating rack level solutions. Yeah. So it's not everywhere do customers have to, purchase the server and then rack it themselves inside of the rack and worry about all of the fluid distribution inside of the rack itself. Many OEMs are packaging their full solution into a rack. So then if you do lean on your partners, you can lean on your data center service provider partner for the actual liquid infrastructure that's going to the rack, and then lean on your OEM partner for building out the rack itself. And then from a customer perspective, it's really just same thing, rolling in a rack and hooking it up. But as opposed to historically when you'd hook up the power, now and the networking, now you're hooking up the liquid as well.
Okay. So, we've talked a little bit about some of the added complexity of liquid cooling, but I'm also hoping to demystify some of that here in this conversation with you as well. Can you talk a little bit about the different components of a liquid cooled system in the data center?
Yeah, absolutely. So we talked a little bit previously when we were talking about the augmented air cooling. Really, we're extending the facility water infrastructure first. And that's what we call the primary loop. So we'll extend that closer to the customer deployment, and then that will land in a CDU, or a coolant distribution unit. That essentially operates as a heat exchanger. And then from there, there's a second loop that's just isolated to the customer deployment that distributes fluid to each of their individual racks. So those are the primary three components that we'll see in liquid cooling. And really that CDU there, it allows us to, one, isolate the customer deployment from our facility water infrastructure, and then also allows us to set certain parameters in terms of the temperature that you want to see at the racks, the amount of the flow rate, the pressure, et cetera.
So that's obviously a good amount of sort of new componentry.
Right.
But, I think that, again, by leaning on partners, right, I think there's some level of simplification that can be added to that. One thing we haven't even talked about yet is sort of the power piece.
Oh, yes.
Right. And when you see, enterprises going out and deploying these, power intensive systems, are they typically, going and procuring power directly from the utilities? Or are they working with a data center provider? How are they solving for the amount of power they need to power these systems?
Yeah, absolutely. So I'd say with the sheer amount of power that's needed, and especially how compact these racks need to be to one another, we're really going to see data centers grow in density. So higher density data halls, higher density facilities that are able to accommodate these high density racks. So really finding that power and contracting that power with the utilities, the data center providers will take on a lot of that burden. But then from a customer standpoint, the data center provider, we need to be ready for whatever racks come in. And racks are coming in now with 100 plus kilowatts. The power distribution is a big challenge as well. These 100 kilowatt racks require, sometimes 8 feeds of 400 volts power to each individual rack. And when you look at that distribution, that's a big challenge. And then also on top of that, it's not always your standard primary redundant power redundancy anymore too. Sometimes we're seeing a 4-way redundancy, or 4 to make 3 at these racks. And so being ready for all of those different workloads is kind of how the data center provider can support customers in that way. And
I'm assuming that, you mentioned the, needing 8, 400 volt whips, right, per rack, and, the new redundancy topologies. I'm assuming that all requires a sort of downstream sort of re-underwriting of the power infrastructure in the data center, whether it's additional UPSs or RPPs. Do you see enterprises sort of designing that in their own on-prem data centers? Are they coming more to partners to sort of help them?
Probably not as much. When we were looking at some of those custom redundancies, it'd be really challenging to do something like that on-prem unless you kind of have a very extensive facility and staff. But I'd say a lot of customers are leaning on partners and data center providers to be able to support them in some of these new challenges.
And that's the power question. I think that there's also another level of sort of complexity around the connectivity when we're talking about these, AI, training deployments. Can you talk about the amount of sort of intra-rack connectivity needed on a SuperPod deployment and what that means for how you design the data center footprint?
Yeah, so because the cabling, like we as we discussed, like point to point for GPU, right? So quite a bit of cabling between the racks. So you really need to get those racks as close as possible together. And so from a facility standpoint, it's really making sure that you can accommodate those densities and accommodate multiple 100 plus kilowatts per rack cabinets aligned next to each other. But then also making sure that you, and just thinking about the infrastructure, right? That's needed to not to distribute the power, to distribute the networking, to distribute the fluid, and how do you organize all of these components in a way that's neat, compact, and does not interfere with one another? So that's another thing from a data center provider perspective that we're doing to make sure that we can have all those components distributing everything that the customer needs at their racks. Throughout the cage.
It's almost a little bit like 3D Tetris, right?
A little bit,
where you put all these different components
exactly.
and infrastructure pieces, right? So thank you. So I guess, in closing thoughts here, liquid cooling and sort of densified AI deployments, I think introduce a lot of new sort of complexity and challenges in deploying in the data center, right? And I think that the industry is moving to sort of simplify how that works, whether it's the OEMs, providing, pre-racked solutions or rack-based solutions, or it's colocation providers providing standardized footprints for these things, or it's the liquid cooling vendors, right? Driving solutions that are, specifically accommodate some of these technologies. Would you say that it is, better for an enterprise to sort of try and figure it out on their own, or to try and work closely with these different partners to just sort of make sure that they're optimizing their solution and their footprint?
Yeah, I would not recommend doing it completely on your own. I think there are so many things happening in the industry right now. I mean, some of the things we talked about are even things that are happening now, but everything's changing at such a fast clip. We don't even know where everything is necessarily going to go. So I'd say not doing it in a bubble, working with partners, working with your OEM partners and cooling vendors, and especially data center providers to ensure so that organizations can really focus on what this compute infrastructure is doing for their business, right? Take all of the challenges and the logistics off of your plate and work with your partners to help you with that.
Yeah, and I think, we've seen just really incredible collaboration, right, and willingness from whether it's the OEMs or the chip makers or the liquid cooling solution vendors out there, a willingness to really sit down at the table with the different parties and make, design solutions that work.
Yeah, absolutely.
So we have a few questions coming in. I'm just going to get into the On24 app here and see what we've got. Okay, so first question from Tariq is, how do I know if I need liquid cooling?
Thanks, Tariq. That's a great question. So really, we talked a lot about collaboration with partners today. So really working with your OEM partner to determine if you need liquid cooling. And really, it's going to come down to the chipset. So if you, for performance reasons, want to use a chipset that requires liquid cooling, inherently, you'd need direct-to-chip liquid cooling to support that. But if you're looking at a chipset that can go either way, it'll be about working with your OEM partner to determine if the efficiency gains will make sense for you to go liquid cooling or air cooling. And then finally, for the augmented air cooling technologies that we talked about today, like the in-row coolers and rear door heat exchangers, you can work with your data center provider partners for that, letting them know what expected air cooling density you expect to have. And then we can run CFD models and provide guidance to customers on what type of technology they should leverage there.
Great. We've got another question coming in from Sebastian here. how do you ensure mission critical reliability?
Yes, this is a good question. Having liquid in the data center is a little unnerving for many people. So we want to make sure we have mission critical reliability. And really the way we do that is through controls. So there are a lot of different controls that we can put in place in a liquid cooling deployment. One, if we take a look at the CDU, there's a lot of parameters that we can have visibility to for the CDU through our BMS system, like the temperature, pressure, flow rate, things like that. And then same goes for the branch level to the cabinet. So you can put flow meters, temperature and pressure sensors on the branch so you can see what's going to each individual cabinet. And on top of that, leak detection sensors throughout the deployment. And we can also put in isolation valves, automatic shutoff valves, and things like that to ensure mission critical reliability.
Okay, I think we have time for one more question. So coming from Gianna, what is the simplest route to deploy liquid cooling?
Yeah, the simplest route. Liquid cooling is not easy nowadays, but the simplest way I would say, again, it's really about collaboration, working hand in hand with your partners. So working with your OEM partners to make sure that you're, purchasing the equipment that will make the most sense for you and the performance that you need and the workloads you're trying to operate. And then also working with a data center provider that is focused on liquid cooling and understands the importance of that technology in the industry right now. So for example, Equinix, this is a really big focus of ours. New phases of our data centers that we have opening up, as well as brand new facilities, will have elements of liquid cooling infrastructure pre-built so that we can be ready to support customers as fast as possible.
Awesome. I think that's all the time we have for live questions. We'll take all the other questions in the chat and we'll respond to them later. But thank you so much for joining us. It's been a real pleasure and look forward to doing this again.
Yeah, absolutely. Thank you.